Hello everyone. Today we're going to be talking about tabular integration. What is tabular integration? It's really just integration by parts. So I've gone ahead and written the formula for integration by parts. Now in this video I'm going to assume that you're familiar with integration by parts, that you've done some integrals using that technique. Okay, what is tabular integration? Well, it's really just constructing a table with rows and columns, and then getting the integral from the table. Okay, how do we build that table? The first column, it starts with u, and then in that column, going down, I take derivatives. So the derivative of u, of course, is du. In our middle column, I simply put a plus sign, and then I alternate pluses and minus. So the next row will have a minus. Finally, in my third column, I start with the dv function, and in this column we take integrals going down, as opposed to this column where we took derivatives going down. So what's the integral of dv? Well, it's just v. And finally, to finish, I draw a diagonal line below all the pluses and minuses. In this case, it's just 1. Okay. You might be thinking, why am I doing this table? Well, look what happens. When I multiply the two functions at the end of the diagonal line, I get uv. And then if I integrate everything that's on this last row, including the sign that's here, I get minus the integral of v du. What do you know? Our integration by parts formula magically appears. There it is. Okay, as usual, this will probably make a little more sense when we dive into an example. So let's do it. Okay, x cosine x. Well, traditionally we would say, okay, u equals x, dv equals cosine of x dx. Let's actually do it in the traditional way, and then we can compare when we do the tabular way. Okay, so we would say u equals x, and we would say dv is equal to cosine x dx. And then we would find du, which is dx in this case. We would integrate dv, right? What's the integral of cosine of x? It's just sine of x. So we say v is equal to sine of x. Okay, what would we do next? Well, we would multiply the u and the v function to get uv. And maybe I'll even draw a little line here so that we can remember that, right? So we take u times v, which in this case is x sine of x, minus the integral of v du, which is sine x dx. Okay, now in many cases, you would stop here, well not stop, but you would just do the integral as usual, right? Because we can figure out what the integral of sine of x is, and you would get your answer. But let's keep going. This will make us have a better connection to the tabular method when we do it next. Okay, so I'm going to rewrite the integral that we have up here. There's absolutely no reason why we can't apply integration by parts to this integral as well. In this case, I'm going to set u equal to 1. No reason I can't do that. That's a perfectly good function. And dv is going to be sine x dx. I do the same thing I've always done. But in this case, notice that when I take the derivative of u, I'm going to get 0. And the derivative of v is going to be, the integral of dv is going to be minus cosine of x. When we integrate sine x, we get minus cosine of x. I'm doing the same thing I did before. Most people don't do it this way, but again, we want to make that connection when we get to our tabular integration. Okay, so as usual, what would I do to find this integral? I would multiply u and v, and I get minus cosine x. And then I would integrate v du. Well, of course, that in this case, that's just going to give us 0. Okay, so now we can combine all of these things. I have my answer, the integral x cosine x dx equals x sine x minus, okay, so we're going to subtract the integral over here, which was minus cosine of x. Okay. And then you might want to put a plus c. I'm not going to bother with the plus c for this video, right? So don't worry. I imagine you'll know that it's still there. I just want to focus on the integral itself, which in this case is x sine x plus cosine of x. Okay, that was our answer using traditional integration by parts. Let's try it again using tabs. It's what we call tabular integration. Here we go. And you'll see a vast difference in how quickly we get this done. First, I put my u function in one column, and I take derivatives until I get down to 0. Okay. The middle column starts with a plus and alternates. Finally, the third column begins with the dv function, cosine of x, and now I take integrals. Okay, if I integrate that, I get sine of x, and if I integrate sine of x, I get minus cosine of x. I draw two diagonal lines, as so. Okay, the process is multiply the functions at the ends of the diagonal lines using the sign above it, so I get x sine x. Now here I have a minus sign and another minus sign. That's going to give me a plus sign, plus cosine of x. And then finally I integrate everything on the last row. Well, that's just going to be 0. That was it. I got my answer very quickly. Notice how we have two diagonal lines, x sine x and 1 and minus cosine x. If I go back to our work from the regular integration by parts, notice how those two diagonal lines show up again. And that integral that was v du with a 0 in it, that's also here. That's how we got that third row in our table. So if you look carefully at these two examples, the same integral, but different method, you'll realize that it's really the same to use tabular integration. We've just dropped all the u's, the v's, the dv's, etc. Okay, now let's do an example simply using tabular integration. And tables, or tabular integration, or tabs, can make this integral, this type of integral, much more quickly. Okay, as usual, I'm going to put x squared, my first column, that's our u function, and I'm going to take derivatives, 2x, 2, 0. Middle column starts with a plus, and then I simply alternate. Finally, my last column is my dv function, e to the x. Well, that's a nice one to have because integrating that is as easy as anything since it's the same function. Draw my lines, and this is just to guide your eye. That's all they're there for. Some people don't use them. It's just to guide you as to what functions you're multiplying. Okay, so multiply the functions across from the diagonal line using the sign above the diagonal line, and I get the integral of x squared e to the x dx equals x squared e to the x minus 2x e to the x plus 2e to the x, and then the last step is to integrate across the last row. Well, that's just going to give me 0. That's my answer. With standard integration by parts, boy, you're going to do a lot of u's and dv's. Okay, let's do another. E to the x sine x. Now normally we would set u equal to one of the functions in the integral such that when I take successive derivatives, eventually we get 0. In this integral, neither one of these things is going to do that. So let's just power ahead, and I'm going to set u equal to e to the x, and the dv function equal to sine x. And as usual, a plus sign in the middle will alternate plus minus plus. Okay, left-hand column I take derivatives. E to the x, e to the x. Right-hand column, I'm integrating. What is the integral of sine of x? Well, that's just minus cosine of x. Just got to be careful and straighten your mind, right? The derivative of sine of x is cosine of x, but the integral of sine of x is minus cosine. The integral of minus cosine is minus sine of x. Sometimes just to check this, I take derivatives going back up just to make sure that I'm getting the right thing. Derivative of minus sine is minus cosine, and the derivative of minus cosine is sine. Looks like we're good. Okay, draw my diagonal lines. Diagonal line. Okay, we're ready. So, integral e to the x sine x dx equals, okay, that first diagonal line gives me minus e to the x cosine x. The second diagonal line gives me e to the x sine of x with a plus sign because I had two minus signs, which give me a plus sign. Finally, I integrate across the last row, and that's going to give me minus integral e to the x sine of x dx. Now, that might look terrible, but it isn't. This is the same integral that's on the left-hand side. So I can bring this integral over to the left, and I get two of them. 2 e to the x sine of x dx equals e to the x sine of x minus cosine of x. Finally, I divide by 2. That wasn't a very nice integral sign, was it? Integral e to the x sine of x dx equals 1/2 e to the x sine of x minus cosine of x. That's it. That's our answer. Again, you can get this entire result using integration by parts in the normal way. But with tabular integration, or tabs, we get the same answer, I think just a little more quickly. Well, that's it for this video. I hope you enjoyed it, and I'll see you next time.